that we will discuss about chemical bonding today. What is a chemical bonding? The definition of the chemical bonding is simple: the attractive force between the species which holds the atoms or ions together. This is only a simple attractive force is called chemical bonding. So, we will get the doubt about that why the atoms are hold together and why attractive force is existed. There is a two ways. There is two reasons why the atoms are having in a bonding. First main reason is the net attractive force between the species is greater than the repulsive force. So this is the main reason why the atoms are holding together. The second reason is that every atom try to achieve the octet configuration or doublet configuration in its valence shell. So these are the two reasons why the atoms are attacked together. So simply we can say the simple definition: attractive force which holds the atoms together. Attractive force is greater than the repulsive force. So second reason is every atom try to get the inert gas configuration. Tendency to get inert gas configuration. To explain this chemical bonding, there are many theories are there. We will discuss one by one. First theory is Cossel-Lewis theory concept or Cossel theory concept. What the Cossel theory concept is saying that is every atom try to get the 8 valence electron in its outermost shell by sharing or gaining or losing. So this is what the rule called that octet rule. So octet rule means octet rule. Every atom try to attain the 8 valence electron in its valence shell by sharing or gaining or losing. So there is a two ways the atoms ready to achieve the inert gas configuration. In that first way is maybe complete transfer of electrons from one atom to another atom. This is the first way. In this way, the electrons are completely transferring from one atom to another atom. So this is a process we can refer as electrovalency, or the bond formed, the chemical bond formed in this way is called ionic bond or electrovalent bond. Ionic bond means simply the bond formed by complete transfer of electrons. So let's go with the ionic bond definition. Ionic bond or electrovalent bond. In this bond formation, electrons are completely transferring. So complete transfer of electrons takes place. Example, let's take the example of the ionic bond here. Formation of sodium chloride. The formula of sodium chloride is NaCl. In this NaCl formation, ions are involved, then sodium atom ready to lose the electron from its valence shell. First of all, let's go with the electronic configuration of sodium. Sodium atomic number is 11. 11 means that we will fill the electrons. It contains 11 electrons and we will fill the 11 electrons according to the Aufbau principle. So 1s2, 2s2, 2p6, 3s1. There were 11 electrons we filled now. This is the first shell which contains the 2 electrons. This is the second shell contains the 2 plus 6, 8 electrons. And it is a inert gas, nearest inert gas is the neon. So if it is lost the 1 electron, it becomes into neon atomic, neon inert gas configuration. Like we will see the formation of the sodium ion, that Na plus ion by losing 1 electron, completely losing 1 electron. Now, in the same way, let's talk about the chlorine. Chlorine is according to octet rule. What we discussed about the octet rule is simply every atom try to achieve the 8 electrons in its valence shell by sharing or losing or gaining. So let's go with the chlorine. Chlorine atomic number is 17. 17 means it has the 17 electrons. So I will write the whole electronic configuration of the chlorine is from the neon you can say up to the neon it has a 10 valence electron, 10 electrons, and after the neon there is 7 is there. You need to fill the 7 electrons. 3s2, 3p5. This is the electronic configuration of chlorine. So it is a very near to the argon. Argon atomic number is 18. If it is gained the 1 electron and it becomes into 18 electron, in total it becomes into organic electron, argon configuration, argon electron configuration. Then it try to gain the electron. So whatever the electron lost by the sodium, the same electron is gained by the chlorine and becomes into Cl minus and reaches into the argon electronic configuration 3s2 3p6, and it achieves the 8 electron configuration in its valence shell. Same way, sodium is also achieves the 8 electronic configuration by losing and the chlorine by gaining. So simply the two ions we found here, that is Cl minus and Na plus together, and you will write as NaCl, the net attracting force is greater value then the repulsive force. You can say the positive ion, negative ion can attract each other and will form the crystals of NaCl. This is the example of complete transfer of electron, and it achieves the octet configuration in its valence shell and the both sodium and chlorine. Sodium is completely losing and chlorine is gaining the electron. So this is got the one of the way to achieve the octet configuration. Like second way also there, that is the sharing of electron between the atoms. The sharing is also a two ways. So we will see the first thing is sharing of electron by the two different atoms or same atoms. Usually sharing, we will go with the sharing the second way. That's what covalent bond. First of all, we go with the definition of the covalent bond. Covalent bond means mutual sharing of the electrons between the atoms and which we can form the chemical bonding is called that covalent bond. The bond formed by mutual sharing of electrons is called covalent bond. So let's go with the one example that you will understand better. Chlorine and H2 hydrogen. The octet rule you can go with that. This is a hydrogen atom and another hydrogen atom. So both are having the one electron and both can share the one electron each other. Usually both will share existed as a H2 gas. So two electrons of the two hydrogens. So this is what the electrons sharing by the two hydrogen atoms and forming the bond is called the covalent bond. So this is not octet rule, it's a doublet rule. So particularly we will say about the hydrogen, it follows the doublet rule. Why? Because nearest inner gas to the hydrogen is helium. To achieve the helium electronic configuration, it required the two electron in its valence shell. That's why we can say to this one is doublet rule. Another example, that formation of the chlorine gas. So in the chlorine gas, Cl2, formula of the chlorine gas is Cl2, and two atoms are going to combine. See, each chlorine atom contains the 17 electrons. In the each chlorine atom, 7 valence electrons are existed. So the 7 electrons are not sufficient to show the octet configuration. So the nearest inner gas is argon. To achieve the argon electronic configuration, it required the one more electron along with the 7 valence electron. So that's why both chlorines have same atomic number and require the same number of valence electron to achieve the argon electron configuration. That's why we both are ready to share the electrons. Both are contributed the one electron in the bond formation and existed and achieves the octet configuration. That is what that satisfy the octet rule. So Cl, it has already 7. That means 6 is in the pairs. And one is a shared electron of one chlorine and another one is a shared electron of another chlorine. This is the example of covalent bond. There is another way of sharing of electrons. If the sharing of electrons contributed, the shared electrons are contributed by only one atom, but the electrons are shared by the both means, that's called that coordinate covalent bond or dative bond. So there is another sharing. For example, the electron which are rich in the atoms which are rich in the electrons, which is ready to form the dative bond or coordinate bond. So that is also a sharing of electrons. So these are the covalent bond formation and sharing of electrons by a single executed by the single atom. This belongs to dative bond or coordinate covalent bond. Okay. Now let's go with let's stop. 10 minutes and